Good day everyone. I'm Clarence R. Borbano from BSI 1A and I am here to discuss my topic which is high-level languages and its advantages and disadvantages. High language. A high-level language is a programming language that is designed to be easy for humans to read and write. It abstracts away the complex details of the computer's hardware and machine code, making it more user-friendly. High-level languages are typically closer to human languages, both in terms of syntax and structure. The low-level languages, like machine code, is closer to human languages and further away from machine language. It allows programmers to write code that is easier to read, understand, and maintain. So, ang high-level language ko no is designed siya para mapadali ang mga remon sa tao. Like, kunyari mag-code ka or himo ka mga reports, mga program, mas napapadali niya kay nababasa sa machine and imo gin karoyag ipahimo sa iya through machine language. Characteristics. Abstraction. High-level languages abstract away the hardware details. For example, memory management, registers, and etc. So programmers don't need to deal directly with machine code. Second, English-like syntax. The syntax of high-level languages often resembles English, making them intuitive to learn and use. For example, statements like if, while, print are common in high-level languages. Third, portability. Programs written in high-level languages can often be more different types of computers with little no modification. This is due to the use of compilers or interpreters that translates the code into machine language. And the fourth, ease and debugging. Since the code is closer to natural language, it's easier to spot errors and bugs. Fifth and last, less control over hardware. High-level languages sacrifice some control over the hardware to make programming simpler. And we have examples of high-level languages. First, Python, a popular general-purpose programming language known for its simplicity and readability. Second, Java, a widely used object-oriented language that emphasizes portability and can run on any device with a Java Virtual Machine, JVM. And Java is common na sa aton kay ginagamit tayo ni pag-code. And C++, a language that supports both high-level and low-level programming and is often used in system software, game development, and performance-critical applications. JavaScript, mainly used for web development and building dynamic user interfaces. Next is Ruby, known for its elegant syntax and used mainly in web development. Last, Swift, Apple's programming language for iOS and macOS application, widely used for server-side development. Advantages of high-level languages. Ease of learning and use. They are much easier to learn than low-level languages like assembly or machine code, especially for beginners. Second, faster development. Developers can write and maintain code more efficiently, which speeds up development time. Third, readability. Code written in high-level languages is easier to understand, which is more important for maintenance and collaboration. Last, error handling. High-level languages often include built-in error checking and debugging tools, making it easier to catch bugs early in the development process. Next, cross-platform compatibility. Many high-level languages support cross-platform compatibility, meaning the same code can run on multiple operating systems without modification. Libraries and frameworks. High-level languages come with rich sets of libraries and frameworks that simply complex tasks. For example, web development, data analysis, and etc. Disadvantages of high-level languages. Performance. High-level languages tend to be slower than low-level languages because they are not optimized for specific hardware. The added abstraction layers can incur performance penalties. Less control over hardware. High-level languages hide many of the intricate details of how the hardware works, which can be a disadvantage if you need a fine-tuned performance or access specific hardware features. Overhead. The extra abstraction in high-level languages can introduce overhead in terms of memory and the processing power, which can be problematic in resource-constrained environment. Compilation versus interpretation. Compiled languages. It's a programming language that translates human readable code into machine code. High-level languages like C++ and Java are compiled into machine code before execution. The entire program is translated at once, resulting in fast execution but requiring a compiling step. Interpreted languages. Languages like Python and JavaScript are interpreted, meaning that they are executed line by an interpreter. While this can make development quicker, interpreted programs tend to run slower than compiled ones. Hybrid languages. Some languages like Java use both compilation and interpretation. Java is compiled into bytecode, then interpreted by the Java virtual machine. Use cases of high-level languages. Web development. It's the process of creating, maintaining, and improving websites and web application. Languages like JavaScript, Python, and the PHP are widely used in building dynamic websites and web applications. It's the process of creating, maintaining, and improving on web applications. Software development. High-level languages like C++, Java, and Python are used to build desktop applications, from simple tools to complex systems. Data science and AI languages like Python and R are commonly used in fields like machine learning, data analysis, and scientific computing due to their powerful libraries. Example, NumPy, TensorFlow, Pandas. Mobile app development. It's the process of creating software application for mobile device like smartphones and tablets. Swift and Kotlin are used for iOS and Android app development, respectively. Game development. The process of creating a video game from concept to release. High-level languages like C++, with game engines like Unreal Engine, and C with Unity are used to develop games. How high-level languages work. Compiling and interpreting high-level languages need to be converted into machine code, binary, for a computer to execute them. This is done through a compiler for compiled languages or an interpreter for interpreted languages. Next, execution. Once the code is compiled or interpreted, the resulting machine codes run onto the computer's hardware to perform the task defined in the program.